Hi, everybody, and thank you so much for playing this video. This is lesson 4-1, my.hrw, representing linear non-proportional relationships. Non-proportional relationships. Repeat it with me, non-proportional relationships that are linear. So the real world, essential question is, how can you use tables, graphs, and equations to represent linear non-proportional situations? So in this module, you're going to be using all four formats: the table, a graph, an equation, and a word situation. Okay, now let's play the video.
Buying a new car may sound like fun, but you also have to make a lot of tough decisions. You not only need to know the car's sticker price, you also need to know how much it's going to cost to fill the gas tank, and how often you're going to have to fill it.
You can figure that out with equations that show the linear relationship between the number of gallons in the tank and the number of miles you can drive on each gallon.
The total cost for one tank can be divided by the distance it'll carry you. Then you know the total cost per mile. Calculating your cost changes a bit if you're driving an electric car. The sticker price may be a bit higher, but the cost per mile can be quite a bit lower. These amazing vehicles don't run on gas. They run on batteries, but calculating the per mile cost is still the same process. The battery in this car will let it drive about 40 miles between charges, and each charge costs about $1.50. That means it's only about 4 cents a mile to drive. So this electric car is going to cost more up front, but over its lifetime, it'll actually be cheaper. And that's another reason math matters.
You know, when my husband only went up to 8th grade in Mexico for school, and in the beginning, when he bought his first car, I didn't go with him. Oh my gosh, he paid so many fees and so many things that he didn't have to, and now he just recently bought his truck, La Mamalona, and he was ready to spend about like $80,000, but now he actually studied and looked at all the different models and compare prices and everything, and he actually got it cheaper, and we thought it was a good deal. But anyways, it's important that you understand the math, okay, and that you research and that you look at all those costs and everything. That's the difference between, learning and not knowing, and just doing whatever. People are going to rip you off, okay?
You can use an equation to describe the relationship between two quantities in a real-world situation. The equation y equals 3x plus 2 gives the total charge for one person, y, renting a pair of shoes and bowling X number of games at Baxter Bowling Lanes. In the equation, 2 represents the price of the shoes, and 3 represents the price per game, or the rate per game. Make a table of values for this situation. What is the value of y when x equals 1?
So if I play one game, I still have to pay for shoes. So it's going to be $3 for the game plus $2 for the shoes. So that's going to be $5, okay?
Y equals 3x plus 2. 3 times 1 plus 2 equals 5. So the value of y is 5. Now, find the value of y when x equals 2.
So when x equals 2, that means 2 games. So 2 times 3, because I'm going to have 2 games, that's 6, plus the rental shoes, 7, 8. I would pay $8. Now, I'm using this over here to pay it, but to check, but I can also use the equation. The x represents 2, so I go 2 times 3 is 6, plus the 2, that's 8, and that's the y, okay?
That's it. When x equals 2, y equals 8. Complete the table by finding the values of y when x equals 3 and when x equals 4.
So when x equals 3, I go 3 times 3 is 9, plus 2, that's 11. And then for 4, I go 4 times 3 is 12 plus 2, that's 12, 13, 14. Now, notice, this is the table format, this is the equation format, and this is the situation. And notice, I also see a pattern here. From 5 to get to 8, that's 2. 8 to get to 11, that's 3. I'm sorry, 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. So here, the y is changing by 3s and the x is changing by 1s. Okay, what does that mean? That it's $3 per game. This is the rate. Okay?
That's correct. When x equals 3, y equals 11. When x equals 4, y equals 14. What is the ratio of the total cost y to the number of games x for the first ordered pair in the table?
So remember, total cost is the y. Total cost is $5 and the number of games is 1. So I put 1 right there.
That's correct. The ratio of the total cost y to the number of games x is 5 to 1. Now, let's look at a second ordered pair. What is ratio of the total cost y to the number of games x for the second ordered pair in the table?
So the total cost is 8, and the number of games is 2.
Try again. You want the ratio in simplest form, and you want the ratio of the total cost to the number of games.
I don't remember that they said simplest ratio, but anyways, the simplest form, 8 divided by 2 is 4, so it's going to be 4 to 1. I divide both of them by 2. 8 divided by 2 is 4, and 2 divided by 2 is 1. That's how you simplify the expression or the fraction.
That's correct. The ratio of the total cost y to the number of games x is 4 to 1. The ratio between the total cost to the number of games played is not constant. So, this relationship is not proportional.
So we're looking at linear equations that are not proportional. They are not proportional because they have a starting value of 2. As soon as you have the x plus something, that's not going to be it's going to be non-proportional, okay?
The entrance fee for Mountain World Theme Park is $20. Visitors purchase additional $2 tickets for rides, games, and food. The equation y equals 2x plus 20 gives the total price, y, to visit the park, including purchasing x tickets. The table shows the relationship represented as ordered pairs. What is the value of y when x equals 8?
So there's different ways of doing it. One way is you start with the 8, because that's the x, and this is 2 times the value of x. So 2 times 8 is 16, plus 20, that's 36. So I put 36 right here. Another way of doing it is looking at the patterns. Look at these patterns, 0, 2, 4, 6, 8. This is going by 2s. And I look at the bottom, and what is that going by? 20, 24, it's going by 4s, right? Plus 4 plus 4. So 32 plus 4 is 36. So I know that I have it right. That's another way, okay?
Good job. When x equals 8, y equals 36. Now, let's see what the graph of the ordered pairs would look like. 2 points 0, 20, and 2, 24 have been plotted already. Now, plot the rest of the points.
So the next one is going to be 4 and 28, 4 and 28, 6 and 32, and 8 and 36.
That's right. You have located the rest of the points. The points on the graph lie along a line, which makes this relationship linear. The line formed by the points does not pass through the origin. The points form a line that has a y-intercept of 20, which means the relationship is not proportional. Therefore, this is a linear, non-proportional relationship. The first 3 graphs show linear proportional relationships. They all pass through the origin. The graph you just completed shows a linear, non-proportional relationship. Linear, non-proportional relationships do not pass through the origin.
So all of these are linear because they make a line, and they are proportional because they go through the 0, 0. Okay, this one is linear because it makes a line, but it is non-proportional because it doesn't go through the 0, 0. Okay, through the origin.
A linear equation is an equation whose solutions are ordered pairs that form a line when graphed on a coordinate plane. Linear equations can be written in the form y equals mx plus b. When b does not equal 0, the relationship between x and y is non-proportional. The diameter of a Douglas fir tree is currently 10 inches when measured at chest height. Over the next 50 years, the diameter is expected to increase by an average growth rate of 2/5 of an inch per year. The equation y equals 2/5 x plus 10 gives y, the diameter of the tree in inches, after x years. Let's make a table of xy values. To make calculations easier, choose multiples of 10. Notice the ordered pairs in the table. Now, let's see what the graph of the ordered pairs would look like. 2 points 0, 10 and 10, 14 have been plotted already. Now, plot the rest of the points.
So this was the equation. They said make a table of values. You always put x on the top and y on the bottom, or if you have it vertical, x to the left and y to the right. And then because it has a fraction here, the 2/5, you want to choose values for x that would make it easy to multiply by that fraction. So either multiples of 5 or multiples of 10 are fine. That's why you end up with these whole numbers. So then you take 0. 0 times 2 is 0, divided by 5 is 0, plus 10 is 10. Then you take 10. 10 times 2 is 20. 20 divided by 5 is 4, plus 10 is 14. Now I see a pattern here. This one's going by 10, see? 0, 10, 20. And this one is going by 4s. See, 4 and then 4 and then 4, so I can make more. This one jumps from 10, 30 to 50. So that jumped 2 10s. So that's why this one jumped to 8. Okay, so now let's graph the other ones. 20 and 18, 20 and 18, and it's going to be an approximation as best as we can. Okay, 30 and 22, and then 50 and 30. Okay.
That's right. You have located the rest of the points. So the graph shows the fir tree's growth in relationship with time. Which best describes the relationship between the diameter of the tree and the time the tree grows?
So it was linear because it did make a line, but it didn't go through the 0, 0, so it's not going to be proportional. It is linear, non-proportional.
That's correct. The relationship is linear non-proportional. Now let's practice with the...
Okay. So it says, how can you choose the values of x when making a table of values representing a real world situation? Choose the values that are positive. I would say makes sense in context. So you can choose positive or negative, but it has to make sense. So like the fractions, if you have fractions, you want to multiples of the denominator. If it's talking about something that is always positive, always positive. If it's talking about something that is negative, then you choose negatives, okay? For example, games played must be games played. Ooh, whole numbers, because it's number, you're not going to play a half of the game, okay? Let me see. Check my answer. Well done. Let's go to the next one. Two parallel lines are graphed on a coordinate plane. How many of the lines could represent proportional relationships? Complete the explanation. Since they are parallel lines, they're not going to be like one on top of the other, so it could only be one of them. At most, one of the lines could represent a proportional relationship. A line parallel to a line passing through the origin cannot pass through the origin. Okay, so a line parallel to a line passing through origin cannot pass through the origin. It's going to be either above or below that origin. Okay, thank you, and I submit it, and thank you so much for watching the video.